All right. Again, thanks for attending. Improving indoor air quality during replacements and retrofits, part 3, energy recovery. Jim O'Donnell is going to be our presenter. And Jim, take it away.
Hey, good morning, everybody. Thank you, Buck. Just additional housekeeping as a reminder, I can issue a PDH credit for 1.0 credits. Just please email me for that. My name is Jim O'Donnell. My contact information is in the lower left-hand corner. And then once again, just before I get started, wanted to thank coworkers of Buck who spoke, Rick Aditis here, Tim Green, as well as Jim McCoy. All right, so let's get started on part 3. We're going to focus on energy recovery. Just as Buck mentioned, part 1 had to do with improving filtration, and then part 2 had to do with increasing your outside air or your ventilation. All right, so just quick 3 main topics we're going to talk about today. Once again, trying to give a little bit basics and 101 understanding of energy recovery units, as well as the applicable codes that are associated with them. I'll review the recent ASHRAE epidemic publications. I'm going to emphasize the parts in there that talk about energy recovery, and then review its implications. And then the third part is, not just to talk about the theory of energy recovery, but just to give you some suggestions or some ideas that HC&I has available for system applications, for replacement work, as well as retrofits of existing equipment. All right, so energy recovery 101, what is energy recovery? Very basic stuff. Energy recovery device is using your existing return air / exhaust air that's already cooled and heated. For our cases here, it's also filtered, and we're going to precondition the outside air. So just 2 quick diagrams. In the summertime, we have depicted an energy recovery unit. Airflow, as depicted as number 1, is your outside air, is typically very hot and very humid. On the other side of our energy recovery device, in another airstream at point 2, we have our return air. That air is cooler and drier than the return air. As the air, as these 2 airstreams travel through the heat exchanger, our outside air gives out some of its heat, that's sensible energy and latent energy, and then it comes out as supply air at part 3, where it's been cooled and dehumidified. All right. Now the opposite effect happens in the wintertime, where instead of having warm and humid air at part 1, airflow number 1, we have outside air that is very cold as well as dry. Our return air, item number 2, is warmer with more moisture. And then as the 2 airstreams travel through the energy recovery device, the supply air that comes out happy is warmer, as well as has more moisture or more vapor in it. And then just to understand that energy transferred for these energy recovery devices, it's always sensible energy, and then also almost all the times it is also includes latent energy. I can move that little thing. Okay, so why are we going to provide energy recovery? Once again, these should all be basic concepts that you're familiar with. We have to comply with applicable codes. We have to increase the amount of outside air required. We'll save first costs, we'll save the operating costs, and then we'll also improve indoor comfort conditions by pre-treating the outside air and also providing additional stages of capacity control. Just I've highlighted the 2 items that sort of dovetail what we've been recently talking about with the epidemic task force, that they want to improve indoor air quality while still maintaining indoor comfort conditions. All right, so once again, reviewing, there's 2 main bodies or 2 main types of energy recovery devices. The first one is wheels. They are broken down into 2 different products. The first one that I've circled that's more common is known as total, also can be called energy or enthalpy. It transfers heat and vapor, which is sensible and latent energy. There's a picture of a recovery device, rotary wheel 1 down below. The other type that's available is a sensible only that transfers heat. And then just the characteristics that are typical of these wheels is they come in different depths. Typically the packaged rooftop units, where we're at a premium for space, The wheels are typically thinner in depth, 1 inches to 1.5 inches up to 3 inches. And then as we get into larger sizes or more complicated air handlers, makeup air units, energy recovery units, et cetera, like that, we see a wide variety of energy recovery wheel thicknesses, 1.5 inches all the way up to 10.5 inches. And then the main component of energy recovery devices is our matrix or substrate. The picture on the right shows that it could either become in sections or in pieces. The one obviously on the right is it comes in sections. And then that matrix substrate has 2 components. The first, the material that's in the center that transfers sensible energy can come either as fibrous media, polymer, or aluminum. That transfers the sensible energy. And then the latent energy is transferred by a desiccant that could be either molecular sieve or silica gel. And those are each applied to the matrix and the substrate. All right, the other device that commonly used is plates, also known as cores. The most common one is a total plate. The ASHRAE calls these a membrane plate. These transfer heat and vapor, which is sensible and latent energy. And then here's a picture of a core or a plate where you have your 2 airstreams exchanging energy. The matrix consists of a hygroscopic polymer material. That's a mouthful to say. And then the other device that's available is transferred sensible only. In this case, the matrix is made of aluminum or plastic. The picture on the lower left depicts a aluminum matrix. This transfers just sensible energy only. All right, other devices available that we'll not really discuss today are heat pipes with a refrigerant base. They have separate air streams. There's a couple pictures there just showing the 2 coils side by side. They can also be separated with refrigerant piping connecting between them. And then the other device that we won't really discuss that much today, ASHRAE calls this a coil energy recovery loop. I think it's better known as a runaround loop. These are hydronic based with either water, but most of the time contain glycol for freeze protection. And then once again, there's 2 separate air streams. You have 2 pieces of equipment that have coils in them. One is for your outside air / supply air, and the other one is for your return air. You have interconnecting piping between them. And then I've just blown up the the circulating pump station that contains, obviously your circulating pumps as well as some controls and electrical power, to circulate the fluid between the 2 coils. All right. Applicable energy recovery codes, ASHRAE 90.1 has to do with energy. It's been created to establish the minimum energy efficiency requirements of buildings. For energy recovery, there's section 6.5, blah, blah, blah. Exhaust air energy recovery. Everybody, once again, should be very familiar with this chart. It has the number of operating hours per year. I see a spelling mistake, and then we have a, based on the different climate zones and based on the different percentage of outside air versus supply air, it has whether you are required to have an energy recovery device or not. All right. Now, regarding the energy recovery device itself, there's an ASHRAE standard 84 that has to do with the testing of these energy recovery exchangers. The one that we're more interested in is ASHRAE standard 1060. I've crossed out just version 2018 because it's going to be revised in 2021. This standard here goes over the performance rating of the different air-to-air heat exchangers that you have available. The 3 types that you have available, that are in the standard are the heat wheel, the plate, as well as the refrigerant wraparound loop. And then this is your golden ticket, from Willy Wonka that you as designers should always demand on requiring for your projects. There's an ARI certification stamp where the energy recovery device has been certified for ASHRAE standard 1060. All right. So now the 1060 standard establishes test requirements, it establishes your standard conditions. You can look on their website, you can search and view. They have a nice piece of paper summary showing the certified performance data. And then the information that's contained in that certified or what they are testing is the airflows, the thermal effectiveness. This is basically how efficient it is. They go through the air pressure drops, and then for today's presentation, the one item that we'll discuss further is EATR. That stands for exhaust air transfer ratio. That is the air leakage percentage. All right, we'll talk about that further as we continue on today. The last code we'll talk about is 62.1 for indoor air quality. There's a section that has your recirculation limits. When using an energy recovery device, recirculation is permitted. There's our picture down once again of our energy recovery device. Recirculation, excuse me, recirculation has to do with the air that comes from the exhaust return airstream and enters into the outside air supply airstream. That's it depicted there with that red arrow. And then in just today's presentation, want to make sure I'm going to cross my definitions and terms here just because of the products, or rather the documents that I've been referencing. So recirculation will also refer to it as cross-contamination, leakage, and also carryover. And then just what ASHRAE allows for recirculation is air that's considered to be moderate contamination or class 2. This is from toilet exhaust and locker rooms as an example. The exhaust air quantity can be up to 10% of the outside air quantity. And then if your air is contaminated or a little bit, I'll call it dirtier, they use the term severe. This is also known as class 3. Some examples would be air from a daycare sick room, and then general exhaust from a general air from a biological or chemical lab. The exhaust air quantity is allowed to be up to 5% of the outside air quantity. All right, so energy recovery. Next part we're going to talk about is the epidemic task force. There's building readiness, and then the second one is a practical guidance for epidemic operation of energy recovery ventilation systems. Sort of a repeat slide. We have the building readiness that I referenced from October 20th. And then today I'm not going to use the schools and universities. That document basically, we really only had one page regarding energy recovery devices, and it referenced the building readiness guide, and then it also referenced this practical guidance for epidemic operation of energy recovery ventilation systems that was created or authored by the ASHRAE Technical Committee 5.5. You know, there's a date that I used, and then also just an idea of how long it is. So going to the building readiness, here's our section where I'm looking for energy recovery ventilation systems. So page 28, the idea was to create guidance on how to evaluate if an ERV is well designed and well maintained. For today's presentation, I'm not going to talk about maintenance. I'm going to focus on design. Page number 29, paraphrasing. Many building systems have ERV systems. Their purposes, once again, are similar to what I mentioned before. Will provide outside air ventilation, and then also just highlighted condition the outside air to comfort conditions. All right, so page 29, paraphrasing once again, this document focuses on ERVs with exhaust and supply duct co-located in the same cabinet. The two products that they discuss the most are for wheels and fixed plates. And then when they say co-located, what they're considering is this picture is once again from it's been shown, it was in both documents, so I took a snapshot and put it in here. But this is a cutaway of an air handling unit that has an energy recovery device. We have our outside air slash supply airstream on the top. On the bottom, as number 2, we have our return air exhaust air. And then within the picture, we have our energy recovery device in the center there. In the documents, they talk about 2 different types of units. There's one with recirculation and another without recirculation. And then just 3 other components I'd like to point out that I'll talk about a little bit further in depth is filters as well as a bypass damper around the energy recovery device that's typically used or it's required by code for economizer operation. Back to build page 29. Any energy recovery device within co-located ducts and equipment casing has potential for some air leakage. This is once again recirculation or cross-contamination. The leakage rate within the energy recovery exchanger from the exhaust air to supply air is referred to as the exhaust air transfer ratio, EATR. This is once again shown here in our energy recovery device. That EATR is the air that travels from the exhaust air to the outside air, supply air. And then just to understand once again conceptually, for the epidemic indoor air quality, they consider that the exhaust air / return air is more contaminated than the outside air. Once again, with all the indoor air quality, from codes, et cetera, like that, they want you to bring in fresh outside air that is considered to be generally, I'll use the word better than your existing air that's inside. All right. So page 31, paraphrasing, some energy recovery devices are designed to allow as much as 5 to 10% exhaust air transfer ratio. This is within the ventilation standard. The ventilation standard obviously is ASHRAE 62.1. And then on page number 32, well-designed and well-maintained air-to-air energy recovery systems should remain operating during the COVID-19 pandemic. So once again, we want to continue to operate our energy recovery system. Why do we want to do that? Well, if the energy recovery system has been well designed, the energy recovery system will maintain normal outside air ventilation rates, and then it will also maintain proper temperature and humidity control of the space. This is similar in concept to, but we'll end up maintaining better health and combating infectious aerosols. This is similar to what is depicted or considered for ASHRAE 55 on the left, where we have a range of dry bulb temperatures and relative humidity that is good for comfort conditions. And then the other picture is the Stirling chart. Once again, there's been many different versions of this, but just it shows that between 40 and 60%, that is the optimal relative humidity range to prevent the propagation of viruses and cooties and stuff like that. All right. So page number 32, also paraphrasing, good indoor air quality strategy includes dilution of the contaminants and then also a properly designed filtration system. This is once again, two of our three legs of our good indoor air quality, along with the third one is also source control. All right. So building readiness, the term well-designed in the context of this document means there's three definitions or three items that they want you to consider for to be well-designed. The first is the supply and exhaust fans are located correctly for pressure control at the heat exchanger, all right? So this is another picture from the documents that I took a snapshot and brought to here. What they have is 4 different arrangements. Where they have the return air on the top and the exhaust air on the bottom. Just for clarity's sake, I'm showing that the energy recovery device is the rectangle in red, and then the supply fan and exhaust fans are depicted in each of the different positions. So arrangement number 1, 2, and 3 are considered to be good, where due to the fan pressurization, the outside air leakage flows from the exhaust air to the outside air to the exhaust air. This is where the supply air generally has a higher pressure than the return air side. And then arrangement number 4 is something that you never want to end up doing. I can't really say I've ever recall seeing this situation in an energy recovery device, but just once again, due to the fan pressurization, we have the opposite, where the exhaust air that would be considered contaminated leaks into the outside air. So here's that situation where the exhaust air has a greater pressure than the supply air or outside air, and we have exhaust air or just air transferring in the wrong direction. Number 2 is the ERV is sized for an appropriate velocity and pressure drop. Just from our ASHRAE handbook, I found they had a big chart of all the different items and pluses and minuses of each. I just picked out the face velocity as well as air pressure drop. I have the fixed plate. They have the membrane plate, which is the total one. And then they also have the energy as well as the heat wheels, all right? So they have just the various appropriate face velocities and the various appropriate air pressure drops. Just want to highlight that once again, the wheels are the ones that are primarily used most of the time. And then just as the wheels get larger in nature from 50,000 or 70,000 CFM, because of the face area, et cetera, like that, you can go up to 1,200 feet per minute, and then we are still maintaining that maximum air pressure drop of 1.2 inches, all right? So then you have to just be concerned with our epidemic requirements or just suggestions here, where instead of providing the minimum ventilation code, they want you to increase your amount of outside air to go above and beyond your code requirements. And then just as you would expect, as you put more outside air through your energy recovery device, you would have a higher face velocity and therefore a higher air pressure drop. So just be careful of that, all right? Item number 3 has to do with the appropriate seals and purges have been specified or exist for the application. Here's a schematic showing what a purge is. So you have the 2 airstreams separated by a vertical barrier. You have your outside air on the left that becomes your supply air from number 1 to 3. And then traveling in the opposite direction, you have your return air depicted as number 2. If you look on the wheel itself, you'll see a little orange slice that's on the outside air portion. It's right next to the barrier. I've blown it up where there's a piece of sheet metal, and that's an adjustable purge. But what the concept is as the exhaust air starts at the red dot and as it travels counterclockwise, this purge will prevent that exhaust air that's caught in the wheel as it spins from the exhaust air to the outside air side. This purge section will blow the air, that exhaust air, out of the wheel and then back into the exhaust, all right? So this is very good for, obviously, for reducing the cross-contamination between the 2 airstreams. And then the second item that they reference is seals. Seals have to do with the joint or where the wheel meets the frame on the outside and the perimeter, and then there's also at the center as well too. All right, so that was for building readiness. Now we're going to talk about the practical guide for energy recovery systems. This technical document will provide additional best practices where we're going to exceed our minimum ASHRAE guidelines. So objective number 1 is we want to reduce our energy transfer ratio, and then we'll reduce it lower than the 5 to 10% that's allowed per code. And then the second objective is we want to increase our outside air. Once again, we're trying to exceed our minimum ventilation requirements of 62.1, which I've highlighted there with the red box. All right. So on page number 6, they have system design considerations. This is looking to minimize energy transfer ratio. Whether there is exhaust air transfer at an exchanger is generally determined by the fan positioning. So this is similar to, this is referring to the 4 arrangements that I showed previously. Arrangement number 1, I've blown up, just depicting the exhaust air transfer ratio. So item number 1, to reduce your exhaust air transfer ratio, if your static pressure of your supply side air, which is in blue, is at least 0.5 inches water column greater than the return side entering the wheel. This is depicted with 0.5 down there on the bottom. Any seal leakage will move from supply air to return air, and then any carryover will be insignificant. And then obviously both of these items are going to contribute to lower exhaust air transfer ratio, is what we would like to achieve beyond the standard ASHRAE 62.1 standards. All right, so here's another depiction just showing, from the guides. It has the outside air, supply air on the bottom. This is a air handling unit, the return air on the side. We have our wheels, energy recovery wheel shown in the center. For this example, they talk about the supply side had a -2 inches of static pressure. The exhaust side had a -3 inches. Just sort of backwards, basically the -2 inches is more positive pressure versus the return side. So this is something good, which we want to achieve, all right? So under these pressures with the 0.5 inches, and item number 2, if equipped with a proper purge section, once again, our purge section is on our energy recovery wheel trying to reduce the exhaust air transfer ratio. So if you have these 2 items, the guide or the guide talks about you'll have an energy transfer ratio less than 1 to 3%, and in some cases it could approach 0, all right? Item number 3, to help with your minimizing exhaust air transfer ratio, is they'd like the supply air quantity to be greater than your return air. These are the 2 values once again shown here. And then they didn't give a qualification of how much it would reduce it, just the word minimize exhaust air transfer ratio. So I apologize for being a little, boring, or not boring. Anyway, so part 2, increasing outside air. We want to remediate your system with the air. We want to increase the outside air. So if the amount of the outside air ventilation in the existing equipment is to be increased, contact your equipment manufacturer. And then paraphrasing, if you're increasing your outside air quantity, if the unit contains an air side economizer, i.e. it's already sized for 100% outside air, you may only have to modify the controls. That's one situation. And then if your heat exchanger is not sized for 100% outside air, they recommend or just mention that you probably or might have to add a bypass. This is shown here back to our air handler cutaway unit, all right? So paraphrasing, we want to increase the outside air. We want to continue to operate the ERV, but maintain comfort conditions. And then I just added a note, just to remember, we also want to maintain the space pressure differentials. So overall considerations, number 1, if your if you want to increase your outside air, you should basically, speak to your equipment manufacturer about the specifications and the performance rating and see if that is possible. Number 2, if you change your supply and exhaust airflow, you will change your pressure differential at the heat exchanger. Therefore, you will change your exhaust air transfer ratio. There's our picture once again explaining or just depicting your 2 air streams and the exhaust air transfer ratio. Once again, you want to try to maintain the pressure on the supply side at 1/2 inch greater than the return side. And then also it helps to have your supply air CFM greater than your exhaust air. So scenario A, if you decrease your blue airflow, which is your supply airflow, supply outside air CFM, you will decrease your pressure differential and therefore cause a higher ETR, which is something that we want to try to avoid. And then the opposite or another scenario would be if you increase your green airflow, which is your return air, exhaust air CFM, you'll increase your pressure differential, and then you would have a lower exhaust air transfer ratio, which is something we want to try to achieve, all right? Number 3, maybe it's not so associated with outside air ventilation, but if you do upgrade your filtration or your effectiveness, you could change your airflows, and therefore you could change your differentials, which could change your exhaust air transfer ratio. So in our unit here, we had 3 different filters. So filter location number A, if we increase the pressure differential, we're going to lower our exhaust air transfer ratio, which is beneficial. And then if we have a filter that's on the outside air intake before the wheel, if we increase the pressure of, if we increase the filtration of that, we'll decrease our pressure differential, and therefore we'll have a higher exhaust air transfer ratio, all right? Then the standard also just says you must confirm this on a case-by-case basis, all right? So now let's look at, we've talked about the technical aspects of the energy recovery devices. Now let's look at some system applications for your real world situations. Once again, repeat, AC&I has been around since 1977, 2 different locations, support from conceptual design through owner training. Just for today's presentation, I've highlighted our extensive experience of our sales staff. And then once again, we're not just selling equipment running, we're providing equipment, service, warranty, as well as parts. There's a picture of our, some products on our parts store. We do have multiple types available. We have energy recovery plates, we have as well as a heat pipe system shown there on the bottom left. All right, multiple manufacturers, just not going to read all these. You can see these from our line card. Multiple system products. If you're replacing the energy recovery device, we have 4 different manufacturers available that each have their strengths and weaknesses. From a system standpoint, we can provide simple standalone systems, and then with increasing complexity, we can provide package systems as well as semi-custom systems. And then if you do have a very unique or custom application, we can provide custom energy recovery systems for those projects. All right, so just applying energy recovery systems, just in general, the most common one that you'll see would be a rooftop with package DX and then a total energy recovery wheel. There's 3 different scenarios that I just threw out there. One is you have an energy recovery device on a roof, or maybe it could be indoors. You're serving single or multiple units. These units could be all different types of products. Item number 2 would be just the energy recovery device. Instead of serving units, it's being ducted directly into the space, whether it's multiple or single spaces. And then the other item just to consider would be if you have a existing outdoor units that are single or multiple units, you could provide an energy recovery device. Just according to Jim McCoy, when energy recovery systems were first introduced into the code, this was a common occurrence here, where instead of going and retrofitting each of those rooftop units, you could provide a single energy recovery unit serving multiple locations or multiple units and increase your outside air quantity and comply with codes for your spaces. All right. So AAON has packaged rooftop units from 2 to 240 tons. They have wheels available up to 36,000. The wheels themselves are AHRI 1060 certified. We have 2 different types of wheels available. Each of those wheels have these options here for bypass, purge, et cetera, et cetera. And then on each of the 2 different manufacturers, the 2 types available, type A is an AAON wheel. It's OEM from Swiss Rotor. It's made of aluminum. It has a molecular sieve. It's a monolith, or it's in one piece, which traditionally has a larger face area and therefore lower air pressure drop and a little bit better performance. And then the other type is manufactured by Air Exchange. This is a polymer matrix with silica gel. And then instead of having it as a single piece, Air Exchange's claim to fame is pie-shaped sections that make it easier for removal as well as cleaning, all right? And then with each of those 2 manufacturers, they have 2 different sizes available for each of the unit sizes, each of AAON unit sizes. There's a small face area and a large face area. And then, typically, or just understand that the height and width of the 2 air streams remain the same. So if you want to provide more outside air, some things to consider. If designing for new construction, instead of specifying the small energy recovery wheel, let's put in the larger one to provide additional outside air. And then also for retrofits, if you have a small wheel, you could potentially replace it with a large wheel. Just the height and width are okay, but then based on the sizes, they do come in different depths. That would have to be investigated to see if that was possible. And then once again, just to remind you, if you're putting in more outside air, don't forget to add your additional capacity control for your airflow, heating, cooling, as well as dehumidification, all right? Additional energy recovery products available from AAON. They have a plates, membrane and fixed plates. I'm sorry, membrane and sensible only. I got to change that. There it is depicted on the right for a packaged rooftop unit from 2 to 6 tons. And then they also have indoor air handling units with up to 51,000 CFM, and then the wheels are available up to 19,000 CFM. All right, so back to our building readiness. Under our energy recovery system on page 31, they have a blurb that if energy recovery systems for other spaces and building types such as healthcare are designed to minimize energy exhaust air transfer ratio to negligible levels. So negligible means they don't want you to have your 5 or 10% or even 1% of your exhaust air transfer ratios. So a great product available that HC&I represents, available to produce negligible exhaust air transfer ratio is Semco. There's their website in the upper right. They're based out of Missouri since this, I was born a real long time ago. And then they have total and sensible wheels up to 70,000 CFM. They all contain a aluminum matrix. And then they have different types of molecular sieves applied to that matrix. 1, 2, and 3 going from higher exhaust air transfer ratio to lower. The one product that we'll focus on or just talk about is the 3 angstrom. And then also too, Semco has energy recovery wheels available for replacements or retrofits, simple units, as well as custom and semi-custom units, all right? And then, like I said, we'll focus on the true 3A angstrom energy recovery wheel to achieve that negligible exhaust air transfer ratios. So standard features of this true 3A wheel, our exhaust air transfer ratio is 0.045%. This is obviously less than 1%, less than 1/10%. The wheels are ARI certified. They only come in a 10.5-inch depth. And then once again, to highlight, we do love that from a sales perspective, we do love that any performance that we do receive from a program or from the factory is ARR certified, gives us confidence in what we're designing will work for your applications. All right, standard features above and beyond a typical wheel is acid resistant coating. It also has anti-corrosion and anti-stick with Teflon. The anti-stick was created for the casino industries where they have a lot of smoking, obviously still. And then dovetailing into our epidemic task force and recent events, the coating also contains a antimicrobial device that is EPA approved. It limits microbial growth. There's a picture of a Petri dish, looks like a black and white cookie, but on the left you have your bad cooties, and then as the antimicrobial coating works, the viruses and bacteria, et cetera, like that, microbes are reduced, so it looks white like that. All right. So now with Semco's True 3A wheel, their real big claim to fame for a number of years has been down at Johns Hopkins University, where they have a lot of case studies as well as white papers available if you wish to view them. At the David Koch Cancer Center, they put in 2000, they put in 40 True 3A wheels. This was used on laboratory exhaust, which if you're familiar with your ASHRAE 62.1, this is class 4, this is highly objectionable. I really don't see this very, very often. They ran the units 24/7. They had an extraordinary amount of energy saved each year. And then in 2016, they underwent an inspection, and there's a report that they inspected 12 units. They were still functioning properly from a exhaust air transfer ratio as well as heat transfer perspective. And then there was really only cosmetic damage associated with the wheel. And then additionally, for the True 3A, if you want to further ensure negligible exhaust air transfer ratios, Semco has a health and safety monitor system. There it is, very nondescript there. But basically what it does is as the airflow varies from your design conditions, it monitors the temperature and pressures. It adjusts the wheel speed to satisfy your temperature requirements, but it also satisfies your recirculation or just your negligible exhaust air transfer ratio. All right. So other pre-engineered products that Semco has is indoor-outdoor energy recovery units, double wall. They can be fan, filter, and wheel. They have options for some coils. They have the model FV. It's up to 10,000 CFM. This is only for 100% outside air. Just to highlight that because of the size, they do not have the True 3A wheel available. Next, going up as an upgrade with a little bit thicker cabinet, a little bit heavier fans and coils and stuff like that, they have the Elite. Once again, just want to point out that the True 3A, because of the size, is not available. Next, they have their EPS, which is a single wheel product. This one you can get the True 3A. It has 9 pre-engineered sizes available. It's available for 100% outside air recirculation. 9 sizes sizes are available up to 40,000 CFM. I just put in parentheses that they can go up to 70,000 CFM. It just becomes a custom design for that. And then these with a single wheel. Next, Semco has an EPD, which is a dual wheel unit. The dual wheel is traditionally a total as well as a sensible wheel. Among the other benefits of this dual wheel arrangement is you can provide free reheat. Once again, they have 9 sizes, standard up to 40,000, but then up to 70,000. And then the last product that Semco has that really probably gets away from energy recovery is that they do have 2 specialized DOAS units. The first is a Pinnacle. It uses a passive desiccant. The leading air dew point that I've highlighted of 40 degrees or 40 grains. This is traditionally a little bit lower than what can be effectively achieved with DX for your dehumidification. And then for even lower dew point temperatures, they have the Ascendant, where we're using an active desiccant. You can have your grains less than 20 CFM. Those are the sizes that are available. And then just to once again to highlight that both products are specialized in just low energy usage, and then they also provide tight dew point or humidity control.
Hey,
Yes.
just to let you know that the Ascendant goes up to 70,000 CFM.
Is it? Okay. All right. My bad. Thank you, Buck.
Yep.
Okay. Okay. So next, we're going to switch from our wheels. We have Renewaire. Just want to point out once again that we're not the rep in Delaware. That's BSS. There's Renewaire's website. We're using a static, they call it a static plate, but basically it's a fixed plate that provides total energy transfer. There's the 2 airstreams and then a cutaway view of the hygroscopic material that's used. This was founded Renewaire was founded in 1978. They first manufactured the core in 1983. In 2001, or since 2001, they've been AHRI certified. The core itself has a 10-year warranty. It's available up to 11,000 CFM. And then just Renewaire has this available as indoor units or rooftops. They have it as a simple plate, fan, and filter. And then just recently, over the past couple of years, they've expanded their offering for options with coils and DX with remote condenser, as well as a packaged DX unit that's shown there on the bottom. All right. Next, Desert Air. It's not just for pools and grow rooms, auditorium. They are an expert in moisture removal. They have 2 products. It's a Total Air and the Aura series. As I mispronounce that, hopefully not. This is available for indoor, outdoor, water-cooled, air-cooled. You can get this with and without an energy recovery wheel. It's available up to 18,000 CFM. Next, as we get into more custom and specialized products, HC&I represents Annex Air. Just once again, fully disclosure, we represent this in Delaware, but we do not represent this in Philadelphia area, South Jersey. This is rep by Carrier. And we have this for northeasterns and central Pennsylvania. Annex Air is located in Montreal, Canada, been around since 1998. Their specialty, or just claim to fame, is that they have a very vigorous and diverse factory testing available. They're experts on controls, and then traditionally over the years, Annex Air has been very innovative in terms of being one of the first companies to use compressors with variable speed drives. That picture shown there is their special new cabinet that thermal composite cabinet. Excuse me as I stumble over my words. And then Annex Air once again specializes in custom units where you can have dual wheels or dual plates, a mixture of both. And then custom DX, where they have water cooled and air cooled up to 300 tons. And then we've done a lot of projects, or just projects where they have units where it's 100% redundancy, where they have 2 dual air pass on 1 unit, 2 redundancy built into 1 airstream with 2 refrigeration circuits, 2 gas heaters, et cetera, like that. And then the other innovative product that Annex Air is in the process of introducing is a new generation form panel We saw this at the ASHRAE show. It just looks like a submarine almost, but it's very, very interesting, very, new, next generation, new technology for your cabinets, all right? Last two custom air handling units that we have available. The first is Energy Labs, located in San Diego / Tijuana, Mexico. They've been around for a long time, since 1978. Once again, they have a very extensive factory testing. They do have a sound chamber where they can sound test your equipment. They specialize in custom DX as well as evaporative cool. We also represent Thermal Corp as another custom air handling line. This is located in Houston, Texas. This is a division of Naylor, which has been around since 1945. They have a few different styles of cabinets available. Knockdown, really heavy duty welded frames, and then standard tubular frames with and without thermal break. All right. So now, if you, last couple slides here, if you want to have no exhaust air transfer ratio, you would have to select a heat pipe, refrigerant based with the 2 separate air streams, or else a runaround loop that is hydronic based, once again with 2 separate air streams. The company that HC&I represents that has these 2 different products or systems is Heat Pipe Technology. There's their website. It's located in Tampa, Florida, been around for a long time. The heat pipes are AHRI 1060 certified, and then just the heat pipes are available up to 120 feet apart, which is sort of depicted right next to it there with the 2 coils and the refrigerant pipe between them. They're also available as side by side, which is shown in the center top, and then also available as top bottom. All right. Now, the last product that we're going to talk about today is the runaround loop, also by Heat Pipe Technology. This is pre-engineered, prefabricated. Want to emphasize that the controls are already, all the algorithms and sensors, etc. like that are factory installed and designed, which we like from a startup standpoint. It's available up to 100,000 CFM. And then just to tout, a coworker has recently worked on a design where instead of a 1-to-1 heat recovery system with 1 coil in each airstream, the project that he worked on had 8 different coils in each airstream, which, from my perspective, I find that very impressive. So anyway, okay, so last slide here, just a summary. So the ASHRAE Epidemic Task Force, which I see is spelled incorrectly, we have our HVA system. We want to use our HVA system to combat the spread of the SARS virus, the new COVID-2 virus. We want to continue to operate our energy recovery system. We want to provide the outside air to increase our dilution effect. 2 methods to enhance your energy recovery operation, once again, beyond your minimum code conditions. You can reduce your percentage of exhaust air transfer ratio. We talked about the different products for that. And then once again, talked about ways to, what happens when you increase your outside air beyond your minimum operating conditions. And then once again, want to emphasize, we don't want to cause any temperature, humidity, and pressurization problems when we're doing this replacement or retrofit work. And then last, just to tout energy recovery systems that HC&I, solutions that HC&I can provide. We have lots of on-staff experience. I just love it that I've been here now for 2 years, and previous life I dealt a little bit in energy recovery unit, but have a lot of great coworkers that I can call up for questions or advice, etc. like that. HC&I has multiple manufacturers, devices, systems. We have them available from simple all the way up to custom applications. And then just once again want to highlight that if you really need to have negligible exhaust air transfer ratio and use a wheel, would recommend the use of Semco's True 3A energy recovery wheel for those applications. All right. And so here's our really final slide. Just we talked about energy recovery devices for improving indoor air quality. Just wanted to highlight now the seminar will be ventilation design. This will be on Tuesday, December 8th. Once again, will be a webinar via Zoom. We'll go from 12 to 1. And then just to, we'll send out an invitation in the next couple of days for that. But just the trick with kitchen ventilation design, it's a big balancing act between code versus your energy use versus comfort inside of the kitchen. As you can expect with all the airflow and especially the heat being generated for cooking and the humidity, it could become very uncomfortable. There's a lot of requirements for safety in terms of exhaust and fire protection, ventilation requirements, and then also you have to be concerned about pressurization for keeping smells to a minimum as they travel, and then also you know, you don't want bugs and et cetera and stuff coming in from the outside entering into your kitchen where you're preparing the food. All right. So then just once again to remind everybody, please send me an email if you would like to receive the 1.0 credit for PDHs. And then at this time, let's start with the answering the questions. I'm just going to close that.
So question is from Robert Maloney. Can you explain how the bypass dampers around the energy recovery wheel for economizer operation is utilized? How does it actually work?
Okay. So, so typically the energy recovery unit is sized for amount of outside air. That outside air operation is used, you know, in cooling and heating. As your ambient temperatures get closer in temperature and humidity to your space conditions, that was when you would use your energy, you would back off the use of your energy recovery wheel and open up these dampers. So typically the operation is the as your conditions get closer to economizer operation, your wheel ends up eventually slowing down and stopping. And then as your airflow increases for your outside air damper, those bypass dampers would then open so that your economizer air is traveling through two paths through your unit. It's traveling through the wheel as well as the bypass dampers.
Okay. Can you send the slides for our use?
Yeah, I've already sent that, but yeah, I can resend them for sure.
Okay. Just to let everybody know, this webinar is being recorded. If you go to YouTube and type in HC9 Company, it has a video recording of all of our webinars we've done since May. You know, we don't have very many subscribers, but people are going on and watching the videos as needed, or you can reference it for one of your customers. And if there's anything you need from us, you know, you reach out to Jim or myself or your salesman, and we'd be more than happy to set something up specific for you and your staff, or if you have a particular customer that you need to get us in front of to talk about these things, we'd be more than happy to do that. Any other questions? Okay, we'll stick around here for a couple more minutes in case anybody has some questions. Otherwise, we really appreciate you attending today's webinar. Again, we will be having another one on December 8th, correct? On kitchen ventilation, and we'll be sending out that invitation very shortly. Also, at the bottom of that invitation, Desert Air is doing a national webinar on grow rooms. I know we did one back in June, but if you missed that or you would like to attend, the link for that webinar will also be at the bottom of our invitation. So thank you again for attending today, and hope you have a great week. Happy Thanksgiving.
Thanks, everybody.